Good evening, everyone. So it's the final talk of Mobile Era here in Freya. I hope you look forward to hearing from Etienne about mixed reality for social good. So please welcome him on stage.
So, can you guys hear me? Yeah, it's working? Okay, it's a good sound system. All right, awesome. So, hi, Etienne. Nice to meet you all. Coming from Montreal. I had a nice time coming into the country. It was interesting. Anyway, so I have a little story today. In 2009, I had a nice little job as a Java backend dev. I'd gotten a bit bored of that kind of work by then, and that's when I started developing on Android as a hobby. So I was really looking, for ways to get better at it and maybe turn it into a career at some point. It was just a thought at that point. So I started attending my local Android developer group. That was kind of a big reveal for me. The thing is, communities like that are kind of magical. So you go in, right? You meet new people. You come up with crazy, ambitious ideas. You try to build them at hackathons. And you end up learning a ton of new stuff. So before long, I got a bit addicted to all of this and became an active member of the community. So started giving talks like today, or volunteering in workshops, even organizing some of those hackathons. And a couple of years after that, I joined Osmos Academy. So Osmos is a non-profit that was founded by good friends in our local community. I met the Osmos founding team while attending something called WearHacks. So as you could guess, WearHacks is a wearables hackathon that used to be running a few years ago. So I attended that hackathon with the idea of building some new input devices for VR experiences. Although that's a couple of years ago, right? So we're talking about Google Cardboard, nothing super sophisticated. But it was a very interesting experiment, and the people I met there were also very much into this idea, and we sort of formed a bond. So with all this interest in VR and wearables and all of that, this carried over into what we were trying to do at Osmos when I started getting involved. So Osmos' general idea behind it is to teach social-minded volunteers about emerging technology. So Osmos puts a strong emphasis, though, on improving accessibility to emerging technologies in question, but also we emphasize three core values, and those are engagement, inclusion, and diversity. And that creates a powerful mix that attracts a lot of volunteers from all sorts of walks of life. So these people are super motivated to learn, and they're also super motivated to make a difference. And it's a really great crowd to be working with. But when we started up Osmos, a question came up, right? We loved VR and AR. We'd like to do something in the social space with that. But how do you actually build social good with VR, right? So we started looking at direct applications of it. VR can be an awesome learning tool. So here we're going to see VR Google Earth. And if you think about geography, this app really turns what could be a boring subject for some people into an eye-opening exploration of the world, right? You're like a giant looking over Grand Canyon or the Empire State Building. I mean, this stuff is pretty awesome. It can really sort of turn you on to geography, basically. If you want to create a time machine to explore historical events, so that's an installation in Poland, in Warsaw. You could build any type of simulation, right? You could navigate to the heart of the atom. You could see math equations come to life. You could be inside of an engine that's actually running and see how it actually works. Possibilities there are, endless. What's interesting, though, is that there could be even more very subtle effects of being in such an immersive experience. So this is a link to an article by Chris Nicholson. He's a researcher on Shopify's VR team, of which I'm not a part of, actually. This is just kind of a hobby for me. But in this article, he explains that humans are very visual and spatial learners. So to illustrate that, try to think back to your own high school days. I'm betting, depending on your age, it's kind of difficult to remember the names of your classmates. But if you think in your head about what the floor plan of the school was, there's a solid chance that you have a very clear mental image of what that is, even if it's been decades since you've left school. So when you create virtual spaces that students can explore, you create a very different way of learning. So you can leverage that effect to all sorts of interesting potential ideas. In the field of journalism, we've also seen compelling use of VR. What's life like if you're fleeing from a war zone, if you're a volunteer in a far-off region of the world? So you can share these experiences with people now. And finally, I'm going to talk a little bit about the field of healthcare. There's been a lot of research there into how to use VR and AR for treatment. So you can try to relax patients that are suffering from chronic pain, exposure therapy to treat phobias, rehabilitation therapy. There's a lot of promising areas of research there. And that's kind of where we started focusing a little bit. Our first project at Osmos was a project called VR Passport. It's still ongoing. It's one of our bigger ones. That was launched in 2016. And we bring VR experiences to kids in hospitals. So it's a way for them to sort of get away from their environment a little bit, learn about new technology, have a bit of fun. For these kids, even a small break from the hospital is really a big deal. And in preparation for these hospital visits, Osmos held various workshops for our volunteers that would go there. So we even had VR content creation workshops, courses. We teach people how to build Google Cardboard VR experiences with Unity, for example. So we also had an augmented reality content creation workshop running. So at the end of these, we all even had a hackathon. Google sponsored us and brought in Tango tablets. It was a very interesting experience. We also had some kid-friendly workshops where the kids could come in and decorate the Google Cardboards that we would be bringing to the hospital. So it might look silly a little bit, but these headsets were a really big hit, and they were also a very big inspiration for me. It made me realize something about what we were doing. So I started paying attention at the actual people showing up at our Osmos events and our workshops. And I noticed that we had maybe, I would like to say 2/3 of the people that were not actually very technical people at all, right? And they came in, they were interested in this idea, they wanted to help, and they really got into it. At the end of the day, whenever we'd have even a very technical workshop, everybody was learning something. Everybody would find a way to contribute to the project. Either they'd be doing assets in Unity or doing sound or doing some other thing depending on the project. You did not have to be a programmer to take part into those workshops, and that was really cool. Where do you go from there though, right? Like, how do you take a pool of very enthusiastic volunteers and then empower them to do even more? So based on the experience we had with that VR Passport project, we had some ideas coming up, right? So one of them was to just build a toolbox for the community. We wanted everybody to be able to learn something new, but we also wanted to make the technology accessible. So the question then became, what kind of projects have something for everyone? That's sort of being our focus. So here's an example. This is an Audi mixed reality experiment. Their idea was to scan a real-life model and drop the players straight into it. So while you're watching that clip, step back and put a community organizer hat on, right? This is a really great project. So you have kids that are playing around in the sandbox. They're building a race car simulation rig with a wheel and a steering wheel and a seat. You have 3D modeling. You're scanning stuff with a Kinect. You're programming in the VR simulation. You have a lot of skill set needed there. And you don't necessarily need to be an engineer to participate in this project. There's a lot of stuff to do. Another really big source of inspiration for me came from this game. So Keep Talking and Nobody Explodes is a co-op game. Who here has actually not seen this or has seen it? Well, anyway, I'll explain it anyhow. So one player is the expert with the manual. They know how to defuse the bomb, and the other player in VR is the technician. They don't have the instruction manual. And so the whole game is about communicating with your partner in a clear way and to basically defuse that bomb. It's often cited, I think, as one of the best VR experiences still today. And what's kind of important to point out with this thing is that you don't even really need a VR headset to play. Like, as part of the clip, right here, you're going to see that, these guys are not using a VR headset at all. So that's a powerful idea right there. VR just augments it. And the thing is, VR headsets have a very obvious downsides. They're going to isolate the viewer from the people around them, right? So if you're trying to do social things, you're kind of trying to do the reverse of that. You want to break the fourth wall. But that's solvable, right? If you create a shared experience, what I like to call mixed reality right here, you can achieve that. So that's the kind of experiences we wanted to build when we started building our toolset. And we're going to look at that toolset a little bit right now. So there's a few platforms that we use and a few tools. So one of the platforms is this. It's an Android Things enabled Raspberry Pi. So having Android Things in your toolbox allows you to connect the physical world very easily with the digital, right? You can you can have Wi-Fi, you can communicate with other devices. So that's a very powerful piece of the puzzle. Legos are also very much part of our toolbox. They allow us to prototype very quickly the physical side of our mixed reality experiences. They can allow us to try out ideas really quickly. So the fun thing about Lego as a platform is that you can go very far with it. So this is a kit that you can get from a company called Dexter Industries. And it allows you to connect a Raspberry Pi and plug it into your Lego model, your Mindstorm build, and turn it into the brains of the Mindstorm build. One of the downsides of this approach, though, is cost. If anybody has looked at the Mindstorm kit, it's like about $350 US, I believe. So that's pretty pricey. There are some alternatives. There's this kit called WeDo that Lego also produces, but that's still pretty pricey, and the connectors between these two things do not work together. Lego has been very careful about not making these things compatible, sadly. So that's a bit of a hassle. What we've done to supplement Legos is we've been experimenting with 3D printing our own connector parts. So 3D printers are at a level now that you can actually get pretty good results and actually get Legos that work. That did not used to be true a few years ago. If you want to add 3D printing in your toolbox, Monoprice sells this nice little printer over there for about $220, entry price. So the thing also with 3D printing is if you've never done it before, it can be a bit of a time sink when you start getting into it. What's nice about this specific printer is pretty much plug and play. So you will need to be patient, though, if you actually want to order that. I'm not selling it for them, but it's always out of stock. So just as a side note there. For AR, we're going to be looking a bit later at Ar.js. And for VR, we've mostly picked Unity and Daydream at Osmos. Unity is obviously fairly well-known game engine. And Daydream is a good quality VR. Google Cardboard sort of didn't really cut it in many cases, and it's portable, so that's a nice choice for that kind of thing. All right. So you might be thinking at this point, you got 3 platforms. How do you get them to talk to each other? For a quick MVP, we usually use Firebase DP. So this is not a Firebase talk. I won't be going into details, but if you're not actually familiar with Firebase DB, the general idea is that Firebase is the single source of truth for your data model, and that lives in the cloud. And it's able to do very decent real time if you have a good connection. And all 3 devices will subscribe to this model, and they basically get called upon whenever the model changes. So it's a very simple programming model. So it also is available both on Android, iOS, or the web. So that's a very nice piece of the puzzle. Like it's a nice glue to stick everything together. All right, we're going to explore a little bit the Android Things component of a sample project. So Android Things again supports the Raspberry Pi 3. That's what I went with in this specific example. If you do start your own Android Things project tomorrow, I would actually recommend you grab this board instead, the MX7. It's a lot faster to develop with, and it's generally better supported by Google at this point. This is a Google-backed sort of prototype, whereas the Raspberry Pi, they support it and they want to support it, but it's sort of second-party support, so it's a bit slower at getting updates and all that. And this board, what's interesting is you can connect it with your USB-C port. So that's a very nice upgrade on the Raspberry Pi, with which you need to connect by Wi-Fi to upload APKs to. So that's kind of slow and painful. So MX7, definitely recommended if you tomorrow start your own project. All right, so let's start building an example. Right here, I'm going to tell you a little story here. So we're going to say that in our mixed reality experience, we have players that are exploring the multiverse. Right, we're going to have 2 roles. We're going to have like the explorers that are wearing the VR headset, and we have scientists. Scientists start in a lab, and they're the ones manipulating this model. And this is where they will be assisting the dimensional explorers. Right. In this lab, we'll have an interdimensional portal. Right. That's like your typical trope for that kind of stuff. And it also features a little conveyor belt that the scientists are going to use to transport items to and from the other dimensions. Okay, so we're going to start with something simple to animate this little model, and we're just going to add an LED. We're going to be able to blink the LED whenever, say, the player in VR has something to say to the scientist. So the electronics for this kind of stuff are very simple. Keep in mind it's just like a tool set, right? An example. So when you write into a GPIO pin, so general purpose I/O pin, you can control the state of the LED, on or off. So how do we control this pin software aside? The key here, if you're not an Android developer, this might not seem very comprehensible to you, but the thing you have to look at is first you get a peripheral manager, you get a reference to a pin, and you can write into that pin, and that's about it. So you can change the state that way. In this sample, I used Ar.js to make that LED turn on and off every second. That is possibly overkill. Right. So to make things a bit more interesting now with the model, we're going to be adding mechanical interactions. So in this example, I used a small DC motor to move the conveyor belt back and forth. The electronic side of thing at that stage are a bit less trivial. The main reason for that is that these motors have a bit more voltage required to move, right? So by using that component in the middle here, the L293D chip, you isolate the power for the power used for the motors from the Raspberry Pi's power source. So that way you're sure that the Raspberry Pi won't fry if you start the engine. So if you want to build your own, you can look up the website adafruit.com. They have really great tutorials as well on how to hook up little DC engines to Raspberry Pis like this project. They also have a very nice Raspberry Pi add-on board that you can use to control multiple motors and servos. And the prototype board I showed earlier, the MXP7, is also Pi compatible in the pins. So you can use these hats interchangeably with both sort of hardware platforms. All right. On the Android thing side, again, the code to turn on and off the motor, it's a bit more, like there's a little wrinkle here. It's using PWM, which is pulse width modulation. You just control sort of the frequency of the little sine waves, well, not the sine waves, but the square waves that you see here. And that's used to control the speed of the motor. GPIO pin, wait, oh, I just skipped a slide. Anyway, GPIO pin 20 and 21 are the ones you use to control which way the conveyor belt will go. I think I have a little video there. Yeah, there we go. All right. So, clicker doesn't. So if you're, I don't know why I'm using this clicker. I could do spacebar. If you're new to electronics, the Android Things website here has you covered with a Hardware 101 section. So it's a very nice beginner section. If you haven't played at all with electronics, or like me, we're pretty much a novice, a refresher course here will get you up to speed really quickly. I recommend you check it out if you're at all interested. It's pretty useful. Another good idea is to get one of those types of Raspberry Pi starter electronics kit. Like these kits, I got mine from a local hobby store. There's a ton of them online. A good Pi starter kit will always have a nice little manual that explains also the basic electronics on top. Like it'll give you little plans to follow and little experiments to do. So coupling these two things together can get you really far pretty quickly. And it's pretty open to anybody that's dabbled a little bit with electronics as a kid. So that, again, very good for all the volunteers that might be interested in that kind of thing. So at this stage, our Lego model has the basic components for real-world interactions. So we're going to look at how we can augment it now. So we'd like to see a basic portal effect happening in the doorway here. And we'd also like to see little virtual objects being carried by that conveyor belt into that portal. So let's see how we can do that. Well, actually, I should make a little side note here. My original approach to all of this was to use Google's Project Tango. So that's a technology stack that's created by Google. You have specialty branded, specialty Tango devices. They have extra sensors, extra cameras, really sensible accelerometers. So they really know where they are in space. And this allows a device to have much better tracking and also see what's in front of it. So you can see a point cloud of like objects in front of your device. The thing with Tango, though, is while it's really great and it's really precise, it's not at all what you'd call accessible hardware for most people. And as far as the development side of things goes, it's pretty complicated. So I ended up going with Jérôme Etienne's Three.js Web AR extension. So he's had really great success building AR scenes in 60 frames per second, on 2-year-old Android phones. So the library is web and JavaScript based. That makes the technology super accessible to everybody. It's a really great choice for community projects. Yeah, I'll give up on this. All right, so a little side note, if you're curious about Project Tango at all, I've done a talk in the past on it at TradeCon New York 2016. That's on YouTube somewhere, and is linked to right there. So this talk can show you how to start building your own AR magic window using Tango. So if you're at all interested, I recommend you check out the talk. And you can also leave me feedback. There's links in there on how to reach me if you have questions on that stuff. I'm always happy to answer that. All right, so to get started, for Ar.js, what we need first is a visual marker like this one. So the library, what it does, it's using image recognition on the video feed to find the pattern you see here in it. And then it anchors a 3D scene based on where it sees that pattern. So then what we need to do is to map our virtual model onto the physical one. So the calibration phase involves placing the marker on the model. The key here is that the size of the marker itself is going to determine the scale of your virtual objects. So what that means is, if you see the marker there, we've put on top of it a cube that's exactly 1 unit by 1 unit by 1 unit, virtual units. And your virtual unit is the actual size of the AR marker. All right. So if you ignore configuration boilerplate here, this is the code you need to add a transparent cube you're seeing now and place it on top of the marker. I've also added in this code an axis helper, so that shows you where the axes for the 3D space are lying. You can see them on the model in the picture on the right. So if you're new to 3D, the main thing to remember is that creating 3D scenes with Three.js is very simple. The library is well documented as well, and people tend to pick it up pretty quickly in what we've seen in our own community workshops. So it's a pretty interesting one. All right, so to map virtual objects onto the video feed, you need to take real-world Lego measurements and add them into your simulation. So the arrow marker I printed for this specific demo measured 32 millimeters on each side. So knowing that, that's how you calculate your virtual Lego measures. Finally, another bit of code that shows how to add objects to our scene. So in this case, you can see that we're picking transparent material for the gate, so to give a little bit of an effect. And I should be totally honest with this. I'll disclose a cheat here. The alignment on this stuff is very, very difficult. Like the actual physical marker is not that precise. So the reason I mention it right now is that what's coming up for Ar.js is that it's going to soon support the new AR Core and AR Kit toolkits, both from Apple and Google on the phones. So we're going to soon probably be seeing a lot better precision for that kind of thing. But this is a bit ambitious as far as like precision goes. So just keep that in mind. All right, so we have the real world component of our mixed reality prototype. So we're going to look at the virtual component and what happens on the other side of the portal, basically. So at that point, I was really out of ideas. So I reached out for help. This is Nina, my creative director. So Mr. Halloween guy is trying to get to his friend Birdie Buddy. Yes, all the way in the corner. So to say hi to Birdie Buddy, we need to open 4 doors. Again, imagination, the little white blocks are the doors here. The person wearing the headset will be playing Halloween guy. And the person outside the simulation will be helping Mr. Halloween guy when he faces obstacles on the way, for example. Anyway, here we'll be using Google Daydream and Unity. So in regards to VR, this is a very successful recipe in our own community. Unity, people pick it up really quickly. The tutorials online are great, so it's a good tool for that. To set up your own copy of Unity for Daydream development, you're going to want to follow all the instructions on this page. Few things that you want to note to make things smoother is that you need Unity 5.6 still. Like I think Unity is now at like version 2017. They changed the versioning scheme. That's a thing to note. Also, if you're a day-to-day Android developer, there's a couple of issues you should be aware of. Under the hood, Unity's latest versions, when I wrote this, we're still expecting an older version of the SDK tools. So you're going to want a separate install for your Android SDKs that are going to be used for Unity. So grab the appropriate zip for your platform, then configure Unity to use that install instead, right? And then you're also going to have a few issues with the Daydream controller emulator. We'll see what that is in a sec. But for that to work, You're going to want to edit the emulator client sockets.cs file that comes with the SDK, snapshot of this frame, and you're good. All the links are there. It'll save you a bit of Googling. It's worth taking that photo. I can bring it back up later if you want. All right, and the other thing I tend to recommend to people is to install the new JetBrains C# IDE Writer. Writer has a very nice Unity plugin. You get all the powerful features you're used to with Android Studio. I would recommend to avoid the default Unity IDE editor as much as possible. It's not worth your time, so it's a bit of a troll there, but hey. All right, so if this is your first time trying Unity, say, right, you go back home, you're like, I'm excited about this. Spend some time on the Rollerball tutorial. It's going to teach you all the basics of the world editor. It's going to go over some of the stuff we're going to go over in a few minutes, but you'll be able to sort of get a better understanding of it. That's usually what we run our community volunteers on, so they get up to speed really quickly with that. It's going to teach you basics of camera, lighting, materials. You're going to see how to add scripts to game objects and how to apply physics. So it's an hour really well spent before diving into the VR side of things. That said, once you're familiar with Unity, using the Google VR SDK is actually super straightforward. So you're going to want to add a viewer main prefab to your Unity scene that they provide for you. And that's all you need to get Daydream going. When you then preview a scene in Unity, you're going to have full stereoscopic 3D. And you also can see that in the emulator right there, you're going to see lens distortion. So you have a good idea of what the final product will be, and you don't need to build it and install it on the phone to sort of see what's going on. You can also emulate a user's movement using the mouse, head movement. Right, so to use the Daydream controller, you add another prefab, the GVR main controller main prefab to your scene. When you've done that, under the UI prefabs folder, you find another prefab that's controller pointer. You add that to your player game object. This prefab adds the controller model to the scene. So you can see now the controller model up on screen. So that's, it also gives you an idea of the dimensions that things are going to be for the user. So then the next step is to bring up and install the emulator on your phone. Once you do that, and you connect that to Unity, you're going to be able to use your phone or the actual real Daydream pointer controller in your emulated environment. So that, again, is very important for developing VR. You don't want to be doing the loop where you install. Unity build times are pretty long. All right, so let's get back to Mr. Halloween guy and Birdie Buddy there. We haven't put doors yet in our scene, right? So I'm going to ask you to use your imagination again. How will Mr. Halloween guy move about the board to get to the birdie person, right? So the basic locomotion mechanics in VR are teleportation. So there's a link here for like a full tutorial on how to implement that, but we're going to quickly go over the basics. So general idea again with Unity is to assign a script to object that will react to a click. So using an event trigger component, you can register to interesting events. And in our case, we're going to see what that gives. So we're going to have a color change that's going to happen when the pointer hovers over a teleport pad. And when you click, you change the position of the player in the scene. That's fairly straightforward. Now that we have a locomotion in place, we're going to add the concept of locked doors to the scene. So to make things a little bit more interesting, I've made each door react to a color. So that you have to imagine the little cubes as keys, and each door needs the proper color to unlock. So the player was going to need some way of picking up these cubes, right, to be carrying them around when they want to click on a door. So when that happens, we're going to want the door to unlock and open. All right, so how do we do this? First, we're going to need some way of picking up an object. That's simple enough. We're going to point to the object, we're going to click and store a reference to it in some sort of inventory, right? That's great, but you also need a way to communicate to the user what they're holding. So what we're going to do here is we're going to add a little object here that's going to indicate with a color what object, what key the player is holding right now. So to do this, you add a pick key method to the behavior script of your key object. And then when that call happens, it's going to trigger this pick key method. To finish, you make sure all script instances point to the right things. So you have to make sure that all your keys are basically, coded to respond to the same event. And when it's all said and done, I think I have the demo here. Yeah. So we're going to see that the player is going to point to one of the cubes, and the color indicator is going to reflect what they've selected. So by clicking. And again, you can see like each thing highlights when you hover over it. So that's the same concept, right? Like the object color, like the object reacts to like the pointer being on top of it, changes its own color, etc. All right. So we can pick up keys now, which is great. We're going to want to use them to open doors. So we want to open the doors that block. Unity has a pretty nice animation system that allows you to do this fairly simply. First, you need to create a new animation, which we're going to see how to do here. And once we're going to have that, we're going to be drag and dropping these animations onto the doors we want to animate. Unity is very much about drag and dropping, adding attributes, hooking them up. So it's fairly intuitive for a lot of people who are not familiar with development. Although sometimes it's kind of hard to explain to people where things start from. Anyway, so jumping into the animation pane with our door selected right here, we're going to be able to add properties to animate. So we're going to pick position, and then we're going to select the very last frame of the animation. And having done that, right, we get like from A to B, basically, like that. Then you need some way to actually trigger this animation. So Unity's animator allows us to build fairly complex state machines to control animations. This is not going to be one of those. It's a very simple affair. We're going to have an idle state on start, an open state, and a closed state, and going back to the idle state. So I think the only thing that's really worth mentioning here is that when you animate something in reverse, you just put in a negative speed. So by putting in -1 here, we actually ask the door to close. It's just a thing that stopped me for a little bit when I started out. Anyway, final result, we jump into the simulation. When the user points to the door, we're going to see it open. And we're going to see the states changing as it goes as well. Like that. All right. So that covers actually most of the tools that we teach and use at Osmose. So obviously we're always improving on this tool set, looking at new things. So if you're interested in building similar programs in your own community or would like to share notes with me, please let me know. We'll share contact info. I really love that dialogue with people, and usually we come up with some crazy stuff to do. And with that, I'll say a big thank you to all of you.